In this video, we're going to be learning about resistance. Now, let's get into it. Resistance, from physics, we learn is the resistivity times the length of your material over the cross-sectional area. And we measure that in ohms. And we're going to be going into the whole concept of this later on. So the whole purpose of a resistor is to impede the flow of current. Now, in your circuit diagrams, you're probably most likely are going to see like this. It's squiggly line, very sharp squiggly line, and physically, well, this is like kind of a picture of like what the old ones looked like. You have like this little cylinder, and it has stripes to it, and all these stripes are physically show the value. So there's some with 4 digits. There's some, 4 stripes. There's some with 5 stripes. There's even some with 6 stripes. But for 4 stripes, you have your value 1, value 2, and then your multiplier, and then the tolerance. Tolerance being like how close to that value that it's showing is. And one way to remember the color code is just Roy G. Biv. So it goes from black, brown, red, orange, yellow, green, blue, violet, gold, and white. These are for the first 3 if you have a 4-stripe one. And the colors go from 0 continuing. And for tolerances, usually you're going to see them, most of the ones I've seen, they're either in gold or silver, but they also come in brown, red, green, blue, and violet. Now, in a circuit, if you have a resistor connected to another resistor, we call this connecting them in series, just like this. It acts like just a bigger resistor. All you do is just add them, and you have an equivalent resistor. So we have 5 ohms here, 5 ohms here. Our REQ would be 10 ohms, a 10 ohm resistor. And in parallel, it's another way around. Like when they're both connected to each other at both ends, we have R1 times R2 over the sum of the resistors equals to REQ. And this is a great, resistors are a really helpful thing when we're going to be going into Ohm's law, which is voltage is equal to the current times resistance. And you can manipulate these so you could find different values. So let's say you have to find I and it give you V, voltage and resistance. All you have to do is voltage divided by R and you would get your I, your current. Now let's go into more depth with this equation here. So let's say for this example, you're on a highway and there's multiple lanes. Right? This highway represents our resistor, and the traffic here represents the current. And let's say you're in this blue car here. Right? Let's just manipulate some things. So resistivity is just some constant given for the material. So let's say length. Let's say you have to go from point A to point B. Alright, what would take a longer time? Getting from A to B if it was a long distance, or going from A to B if it's a short distance? Of course, it's going to take a longer time if A and B are farther apart. So as length increases, resistance is going to increase. And let's say let's say cross-sectional area, let's say you have all these lanes, right? What if we closed all these? Okay, let's say we close these guys, and these guys had to go more and more, right? These guys had to merge over to these 2 lanes. Your resistance is going to increase, right? The amount of traffic will increase. Well, if we have all these lanes open, there's more area for everyone to spread out and go their own way. This would be bigger. Area is going to be bigger, and your resistance is going to be smaller.